Hello friends, today in this video we'll learn how to use Microsoft Excel Solver for linear programming based optimization problems. Solver makes linear programming very easy without requiring the difficult methods of simplex and graphical to solve linear programming problems. This video has been prepared by
Bhargav Fukan
and Jayanta Gautam of MBA 3rd semester, Department of Business Administration from Tezpur University. First of all, we'll learn what linear programming is. It is the process of taking linear inequalities relating to some situation and finding the optimal value under those conditions. The objective involved is to maximize the profit or to minimize the cost involved. Now, this programming uses algebraic relationships to represent a company's decision given the business objective and the constraints. So, in this case study, we have taken a toy manufacturing company called Playmax Toys, which is best known for their dolls, figurines, and action figures, which is based in Greater Noida, Uttar Pradesh. And this company produces basically three types of toys, such as Little Krishna toy, Jenna dolls, and Action Men. And the machines that produces the toys are lathe, milling, drilling, and grinding machine. Here, the company wants to find out the actual number of production units of these toys in order to get the maximum profit. So here, given the time required for the 4 machines in producing Little Krishna toy are 6, 5, 6 and 9 minutes respectively. Similarly, the time required by the 4 machines in producing the second doll, that is Jenna doll, are 8, 6, 8 and 6 minutes respectively. And for the final toy, that is Action Men, the time required by the 4 machines are 7, 5, 6 and 8 minutes respectively. And also the maximum time limit for the 4 machines are 560 minutes, 400 minutes, 520 minutes and 480 minutes respectively. So here the values are written in tabular format, and the given that the Playmax Toys earns a profit of rupees 30 from the Little Krishna toy, a profit of rupees 50 from the Jenna dolls, and a profit of rupees 40 from the Action Men toy.
The objective function for the given case study is z equals to 30x1 plus 50x2 plus 40x3, where x1, x2 and x3 are the 3 decision variables, that is Little Krishna toy, Jenna dolls and Action Man. The 4 constraints are as follows, and x1, x2 and x3 are the non-negative constraints which will be always greater than equal to 0. To solve this problem, we will go to Microsoft Excel 2010. For those of you who do not have the solver function, first we will click on File and click Options. There we will find the tool, that is Add-ins, and click Excel Add-ins and click on Go. There we select Solver Add-in and click OK. We see in data the solver tool will come. Now we'll write the contributions for each toy. Here we'll write the profit each toy makes for the company. Little Krishna toy earns a profit of rupees 30, Jenna dolls earns a profit of rupees 50 and Action Man earns a profit of rupees 40. We write down these figures, that is 30, 50 and 40. Now for the constraints, we'll write down these figures for lathe machine, that is 6, 8 and 7, with the maximum available time being 560. So we'll write down these figures 6, 8 and 7 with the maximum being 560. For milling machine, we will write 5, 6 and 5 with maximum being 400. So 5, 6 and 5 with the maximum being 400. For drilling machine, The figures will be 6, 8 and 6. So we write down these values 6, 8 and 6 with the maximum being 520. For grinding machine it is 9, 6 and 8 with maximum being 480. So we write down these values 9, 6 and 8 with the maximum being 480. So we write down the formulas. In E4 we write down this formula equal to B4 into B3 plus C4 into C3 plus D4 into D3. Enter. In E6 we write down the formula, that is B6 into B3 plus C6 into C3 plus D6 into D3. Enter. For the second constraint we write down the formula, which is B7 into B3 plus C7 into C3 plus D7 into D3. Enter. For the third constraint the formula will be B8 into B3 plus C8 into C3 plus D8 into D3. Enter. For the final constraint the formula will be equal to B9 into B3 plus C9 into C3 plus D9 into D3, and then we'll click on enter. So we see that the four constraints are given as follows. Now we'll go to solver. Here for the set objective we will select E4, and as we have to find out the maximum profit, so we'll click on maximum. And for this function, that is by changing variable cells, we will select B3, C3 and D3. Then we'll click on subject to constraints. We'll click on add. For cell reference, we'll click E6, which is less than equal to F6. Then we'll click on add. For the second, we'll select E7. For constraint, we will select F7 and click add. For the third constraint, in cell reference, we will select E8, which is less than equal to the constraint, that is 520. Then we'll click add. And for the final constraint, in cell reference, we will select E9 with the constraint being F9 and click OK. Then we will select this option, that is make unconstrained values non-negative, and in select a solving method we will select simplex linear programming. Then we will go to options. Here we see that we have the option of showing iteration results, but here we are only considering the final solution, so we will not select iteration results. Then we click OK, and then we'll lastly click on solve. Here we see that we have two options, that is keep solver solution and restore original values. We will select keep solver solution and click OK. So hence we get this solution, that is rupees 3300 profit will be earned by Playmax Toys for the day if they produce 50 units of Xanadols and 20 units of Action Man each day with no units of Little Krishna toy being produced. I hope this video will help you in using Solver to solve linear programming problems. With this, I conclude my video. Thank you.